First Spin. Welcome to First Spin, a show where I learn how to use the Parallax propeller without having any prior programming experience. Rather than do this on my own, I have enlisted the help of two
humans.
Whenever I say experts, you always call me out on it.
Yeah, well, you know. I guess after producing this show, I'll probably be an expert because you get into the nitty-gritty details on this stuff and you end up making us explain it from absolute fundamentals. And, you know, after having to answer all these questions and listening to Roy answer these questions, I'm, you know, learning stuff every week too. And I have to do my homework before we start these shows. I have to think ahead and go, okay, what is Addie going to ask us this week? I'd better be ready, or otherwise, you know, it's not going to work.
Yep. So I appreciate it. Anyway, we have Whisker and Roy. Super Roy Eltham.
Hello, Roy.
Howdy.
Hi. So last week we ended on cycles and instructions and ROM, and all that fun stuff. I think next we have the hardware connections. Just a brief touch up on that, and then the boot up procedure, runtime, and shutdown. That sound like fun?
Yeah, you ask you ask about what you don't understand, and we'll explain it.
Excellent. All right, hardware connections. There is a lovely example wiring diagram that shows. It says it provides host and EEPROM access to the propeller chip.
So she's got a schematic there in front of her of the bare minimum of what you need to actually get a propeller up and running. Just the propeller, the EEPROM, a resistor or two, and a prop plug.
Awesome.
Page 17 in the propeller manual.
Correcto. And so I only so it says in this example, the host access is achieved through the propeller clip device, a USB to TTL serial converter.
Yeah, most people aren't going to end up needing a prop plug to talk TTL or a USB, because most of the boards have this function built in. They actually have a USB on the board. And they have that same little USB to TTL converter chip that's on the prop plug, right on the board.
So, so the prop talks in TTL serial, totally awesome serial, and does the PC also talk in totally awesome serial?
They used to. There used to be serial ports on the back of your PC. It's like the universal standard way of communicating. Still is, really, but it's not so useful for consumer level stuff these days. Everybody uses like USB, FireWire, etc., because we have much faster, more robust serial protocols now.
Gotcha.
But still, you get back to that lowest common denominator of TTL logic when you're talking to microcontrollers all the time. And if you were using a computer that had a serial port on it, you could interface directly to the prop.
Without the prop plug?
Yeah.
Oh.
But, most computers, they just don't have serial ports on them anymore. So you need to have something that converts between USB and TTL.
There's one minor correction there. Standard serial port is running at a higher voltage, so you'd at least have to have a voltage level conversion chip to go from like a standard RS-232 serial to the prop plug.
And the older prop boards and basic Stamp 2 boards, they have that chip on them so that you can connect directly from a serial port on the prop board right over to one on the computer.
Right, yes.
I see.
Most of those boards are now obsolete and not even made anymore with the serial port directly on them, at least for the prop. They did make a couple, but
I think for the purposes of first spin here, we can pretty much assume that the boards that people are going to be using have the USB port, and they're going to be able to, connect directly to the computer.
So just
Yeah.
USB. Okay. Well, okay.
So, for example, the quick start board, the demo board, the professional development board, the board of education all have the USB port built in directly with the equivalent of a prop plug on the other side of it. So
now Roy was up at Parallax headquarters this week, and I am hearing rumors. You guys know that Parallax sponsors the show. I'm hearing rumors from Roy that there's some goodies on the way from Parallax for you, Addie.
I think so.
Mm-hmm.
I want to say I am getting a whole bunch of really cool things that they're selling at Radio Shack, and hopefully it's in the Radio Shack packaging so I can like take pictures of it and such. But yeah, so is it certain Radio Shack stores that are getting?
Yeah,
Okay.
they haven't rolled it out to everywhere, but it's quite a few of them, and it's actually also at a few other stores. I don't think it's going to be in the retail packaging.
Okay, well that's fine. I mean that's fine.
But
Saves
it's all the
room
same
anyway.
stuff.
Yeah.
It's also there's a Kickstart webpage that the Parallax is sponsoring that uses all these things, and they gave you basically all the same stuff.
Cool.
So
excellent.
And the new Propeller Board of Education, a beta version of it anyway, is on its way.
Huzzah!
And that'll allow Addie to get started on helping work out all the bugs in the new educational program because they're switching the BOE over to Propeller.
Gotcha.
Right.
By the way, I'm an excellent alpha tester because
She breaks
I don't know what I'm
everything.
doing, but I break it all.
Yeah.
And I can always like redo it.
So Addie will be working with a board that has a USB port on it.
Mm-hmm.
And we also have a few of mine here around the house. One of my favorites is the Propeller ASC board from 1mgh.com. That one's nice and inexpensive.
Cool.
Right.
And I like the My Prop demo board. So I don't have to really worry about the serial business too much. Not yet, anyway.
Does that sufficiently answer the prop plug part of that schematic for you?
For now.
Now, what I find the prop plug to be really useful for is when I'm building a circuit from scratch and I want to put like a 40-pin dip version of a propeller in a socket on a solderable breadboard.
Solderable breadboard. You mean like
a prototype board? Yeah.
Okay.
By not having to include that, programming chip, it makes it very nice. I can just leave a little header there with the 4 pins for the prop plug to jack into. And I just have the prop plug sitting in, my little programming toolkit case.
I see.
And when I want to reprogram that circuit, I can. But, for those kinds of circuits, you're not reprogramming them over and over again because they're not a prototyping platform. They're more of a production thing.
Right.
I see.
And there's 2 versions of the Propeller prototype board that Parallax sells, and one of them just has the little 4-pin header for a prop plug, and it's a couple bucks cheaper than the one that has the USB stuff built in.
I see. Interesting. Okay. Well, that works.
So it's one way
in
to
a pinch.
lower cost if you're doing more than one of them. You
Right.
don't have to put it on. You don't have to have that extra chip on there if it doesn't need to be reprogrammed by the user or all of the time.
Right.
Right.
That makes sense. Cool. Okay. I don't think I have any questions. I mean, we pretty much have gone through all this stuff pretty in depth. So we'll start. We'll start with the boot up procedure. Starting with the boot up, because that's the boot
And we've
up.
actually covered some of this in just discussing the reset and the brownout enable stuff, because what it does is go into the beginning of the boot up procedure when you do that. So
I see.
But
Okay. So upon power up of 100 milliseconds, plus 100 milliseconds?
So after you apply power, 100 milliseconds later.
I see. RESN, the reset pin goes from low to high, because when it's low, it's like shut off.
Right. And just to be clear, 100 milliseconds is a tenth of a second.
Yes.
So it's very quick, but
Right.
it just...
Is that a long time in code time?
It can be, yes.
I see. Okay. Res goes low to high, software reset. Propeller chip starts its internal clock in slow mode. Delays for 50 milliseconds. Switches the internal clock to fast mode. And then loads and runs the built-in bootloader program in the first processor. So I have so say you set your clock in the program, so that doesn't get recognized until the program is actually loaded.
Correct.
Oh.
Which is actually a later step here that you're about to get to.
Oh, okay.
Well, later in the boot up procedure, yeah.
Gotcha. So the bootloader performs one or more of the following tasks in order. Detects communication from a host, such as a PC on pins 30 and 31, that's the transmit and receive. If communication from a host is detected, the bootloader converses or talks with the host to identify the propeller chip and possibly download a program into main RAM and optionally into a 32 KB EEPROM. All right, well, that makes sense. It just, hello, RAM, hello, EEPROM.
We must have done our job in the previous weeks because she's just understanding all this stuff automatically.
I know. It's not so intimidating anymore. If no host communication was detected, the bootloader looks for an external EEPROM on pins 28 and 29, which is, I think, the communication with the must be the communication with the EEPROM. If an EEPROM is detected, the entire 32 kilobyte data image is loaded into the propeller chip's main RAM. So,
right. So just as an extra detail, because you were hung up a little there, pin 28 and 29 are general purpose I/O pins after boot up, but during boot up, they're used to attempt to talk to an I2C EEPROM.
Okay.
And that's what this is saying. So if you have one plugged in, it will talk to it. Otherwise, it will not talk to it.
How long are programs?
Go to the next step.
Okay. How long are programs stored in EEPROM? Like forever?
Pretty much.
Oh, okay.
There's probably some kind of very, very long decay.
Well, yeah. I mean, yeah.
But in general, you could assume it's forever until you program it again.
Okay, gotcha. If no EEPROM was detected, the bootloader stops, cog 0 is terminated, the propeller goes into shutdown mode, and all I/O pins set to inputs. So, okay, you turn it on, and if no okay, so there's no program, like I'm just sitting here turning it on, ready to start playing with it, right? And there's nothing in the RAM, there's nothing in the EEPROM. It's going to shut down?
No, if there's no host connected to communicate with and there's no EEPROM, then it will just shut down. If there is an EEPROM, it will read the data in the EEPROM into its memory, like it says there, and then execute whatever that code is that was in the EEPROM. If the EEPROM is empty, then it will execute nothing and probably just reset itself. Or, it just depends on what's in the EEPROM.
Well, so it should say more like if no EEPROM or host was detected.
Well, it's going, if you look at it's the tasks in order.
So it's like if this
so
works.
It does the first one, and if that doesn't work, then it does the second one, and if that doesn't work, it does the third one.
I see. All right, folks. If it doesn't if it doesn't can't tell it's got a computer or EEPROM, then it's not going to work.
Right.
Okay, gotcha. If either step 2A or 2B was successful in loading a program into the main RAM and a suspend command was not given by the host, Then cog0 is reloaded with a built-in spin interpreter, and the user code is run from main RAM. So, would said was successful?
Okay, so what that's saying is, 2A was the host PC connected to pins 30 and 31 via a USB interface.
Mm-hmm.
If it found a host and the host communicated with the propeller and sent a program to it, right?
Mm-hmm.
Then it would do what it says there. It will load up cog0 with the spin interpreter and start running whatever the host sent down to the main RAM.
The program, yeah.
Equally true if it didn't find a host but found an EEPROM, it will download the code out of the EEPROM into its RAM and then load up cog0 with the spin interpreter and run the code that it's in his main RAM.
Mm-hmm.
So that's what that's saying.
Now,
and the built-in spin interpreter is in the ROM that's inside the propeller, which we talked about in previous episodes.
Right. So then, okay, it talks here about a suspend command. When would you want to give a suspend command for things to not be loaded?
So if there is a host connected when it powers up, like if you're running the prop tool on your PC and you've got it all plugged together,
mm-hmm.
but it's not ready to download a program into the propeller, then it can send a command to say, just suspend yourself and wait.
Okay.
Right. And then later on, when it is ready, it'll send a reset down, which will cause it to go back through the boot up procedure and communicate with it again.
Okay.
So that's just an optional feature that when you're connected to the host, it can send a command during that conversing portion to say, just go into suspend mode and don't actually do anything.
Now, can you as the coder tell it to suspend?
Yeah, there is a command you can put in your code to essentially reboot or go into halt state. I mean, there's a few different ways to go about it, but it's typically only done in like error situations or something.
Oh, because I was thinking like if you were doing things in PASM, for instance, then you wouldn't need the spin interpreter to be loaded on cog0. So you could just tell the thing, hey, stop. I don't want you to.
Well, the thing is that when you first start up the propeller, even if you have PASM, if your whole program is written in PASM, there is still at least a tiny bit of spin, which is in there to launch the PASM code.
I see. So no matter what, you kind of need the spin interpreter.
Right. You need the spin interpreter to at least do that first couple of steps, which are in a program that's all PASM. It's literally just start up a new cog with the PASM code and then halt this cog, which is the one running the interpreter.
Okay. So why don't they just automatically have the spin interpreter in cog0 instead of loading it into there all the time?
Well, because when you first start up, you want to be able to use the cog0 for stuff other than the spin interpreter. So the cogs only have RAM for their code space.
Mm-hmm.
So you have to load it with something regardless. Like whatever you put in there, it has to get loaded when you boot up. So when you first start up, it's actually loading the bootloader program, which does this sequence of steps into cog0. So that's what's doing the communication with the PC host and doing the communication with the EEPROM. Right?
So bootloader,
it's a little piece of code that's running in cog0 right when you first power on the.
So bootloader runs in cog0.
Right.
Oh.
It even says that in the first line there. It says then loads the built-in bootloader program in the first processor, cog0.
Oh, ha ha ha. I guess I did kind of just skip that. I see.
And the bootloader, like I said, is just doing this startup procedure. And then once it's successfully loaded, it then loads the cog or the spin interpreter into cog0 over top of itself.
Oh, wow. It's like kamikaze.
Right. It issues because the command that loads a cog from ROM or from RAM is actually a hub process.
Yeah. Well, it has
And
to
the
be,
hubs,
right?
right, because it has to be able to communicate to the cog and fill it up with stuff.
Right.
And so that's how that works.
So it's like, power's on. All right, bootloader, go to cog 0. And the bootloader's like, I have done my duty here. Kills itself by like loading the spin interpreter, and the spin interpreter's like, mwaha.
Right.
Give
and
me
the spin
fodder.
interpreter starts running the code that's in the main RAM right at the beginning. And if that code, if, like I said, if you program it with something that's mostly PASM, and I say mostly because it has to at least have one line of spin that says, start a new cog with this PASM.
I see. That makes sense.
And, that could actually be cog 0 overriding the spin interpreter right away.
Gotcha. Cool.
Or it could be another cog, right? So it's just literally the one line or a couple lines of code that start everything up.
Cool.
But, obviously, well, not obviously, most programs on the Propeller that are written, even if they're written mostly in PASM, still have a little bit of spin code. Usually for doing things like interfacing with the PASM to other stuff.
Sure.
So like you might have some spin code running in one cog that is reading values back from that have been output by PASM code running in the other cogs, and then sending them somewhere or doing some math on them or whatever. That's the more common thing, is to have a mixture of spin and PASM.
Okay, that makes sense. And I have a question. So say it says if an EEPROM is detected, the entire 32 kilobyte data image is loaded. So say your program is like 16 kilobytes. Does it just like have 16 kilobytes of your data plus 16 kilobytes of blank space that gets sent?
So when the prop tool makes a binary file to send down through the host communication thing at the beginning, it makes a full 32K thing and sends it down, and then it fills up the RAM on the Propeller, and then that gets copied into the EEPROM.
Gotcha.
So it might have 0.
Roy knows way too much about this because he's actually working on the replacement for the compiler in the new prop tool.
Yes.
The conversion, I'm converting the x86 compiler into C.
Gotcha.
So yeah.
Cool. Okay. So I am comfortable with the Bootup procedure then. Runtime procedure. A Propeller application is a user program compiled into its binary form, downloaded to the prop, chips, RAM, and possibly EEPROM. The application consists of code written in spin with optional PASM, which we were just talking about. Code written in the spin language is interpreted during runtime by a cog running the spin interpreter, while code written in Propeller assembly is run in its pure form directly by a cog. I see. Right. Every Propeller application consists of at least a little spin code and may actually be written entirely in spin or with various amounts of spin assembly. You pretty much just said that.
Right?
Nice. Good job. Okay, blah, blah, blah. Once the Bootup procedure is complete and an application is running in cog 0, all further activities defined by the application itself.
Right, so the code you write tells it what to do from that point forward.
Gotcha. And it has control over internal clock speed, I/O pin usage, configuration registers, and when, what, and how many cogs are running at any given time.
Now, I know that's like version 1 of the manual, but for it to actually say blah, blah, blah in there is pretty informal.
Well, I'm just skipping over the stuff that's like, obvious. Right? Like, that spin language is high level and Propeller is low level code.
Right.
That's what I mean. Yeah. Okay. I have a question.
Okay.
You?
Shush. So you have your program in, say, hub memory, right?
Well, that's where it is loaded first,
right,
from either the host or the EEPROM.
Right.
Yeah.
And so it controls. I'm trying to think. Can you make it spawn off a program that, like, into another cog that can control pins from that cog?
That's the only way you can control pins is from a cog. So
you can't control it from the hub memory?
No, because the hub memory is not actually anything other than shared memory. It doesn't actually do very much. The cogs are where you actually run code and interface with the pins and do anything. And a cog running the spin interpreter is reading hub memory a byte at a time to get the spin byte code and actually execute it. But it's actually doing its work in the cog itself. Not, it's the hub is just holding the data.
I get it.
Right.
And then can multiple cogs access the same pins at the same time?
In fact, they can, although there's a section in the manual here that we'll get to where it explains how that actually works out.
I see.
There's a situation where if you have two pins as outputs from two different cogs, the actual resultant output is the OR of the two outputs that the cog set. So if one of them sets it high, it's going to be high, regardless of what the other one does.
And that sounds like a conflict of interest.
Well, it's just that
it's important to be aware of. It's something that you can use to do some fun tricks with. Right. But as long as you understand that if you set it high on either, that it will go high, then, you just keep that in mind.
Because high trumps low.
Well, it's just, like I said before, it's just ORing the output of the two cogs together to produce the actual output.
He means the Boolean operation of OR.
Oh.
Right.
Just like you take a 1 and a 0 and it makes a 1. You take a 0 and a 1 and it makes a 1. You take a 1 and a 1 and it makes a 1.
2. Just kidding.
No.
And a 0 and a 0 makes a 0.
I see.
So if they both set it low, then it will be low. But if either one of them or both of them sets it high, then it will be high for an output. If two cogs are using the same pin as an input, then they will both see whatever the pin is set to.
Gotcha.
So if the external device or connection is setting it low, then both cogs will see it as low. And if it's setting it high, both cogs will see it as high.
Okay. I'm sure we'll go over that.
That's true for 2 or 3 or 5, however many cogs listen to the same pin.
What if it's like... Okay, no. Well, What if it's like... Oh, no. Okay, never mind. I get it. Okay,
because
so...
there's only... When they're all inputs, they're all just reading whatever the pin is set to. Right? So they're all just looking at the pin and seeing the same result.
Right.
When it's an input. When it's an output, it has to do something because they might be in different states. One will be low, one will be high, and what the design of the chip says is that they're all just ORed together.
Thankfully. It would get really confusing if it was like an XR or something.
Or any other weird combination. Like it could be ANDed, and then that would be a little bit more difficult because then for any pin to be high, all the cogs that are attached to it all have to be high.
Yeah.
So can you change that? I mean, can you change it from being an or? No, okay.
No, it's hard-coded. It's built into the silicon of the propeller. That's just how it works.
Gotcha. I blame Chip.
Well, I wouldn't blame him so much as thank him because it makes sense.
Gotcha. So I think we have like 1 minute left, maybe.
You got 30 seconds.
30 seconds. Let's go through the shutdown procedure. Huzzah! I'm sure we'll go more over the OR stuff
I don't think we have time this week, but we can pick up there next week.
Darn.
All right.
All right. Next week.
Thanks for listening, everyone. And thanks to Parallax for sponsoring the show. We really appreciate it.
Yes.
As I'm sure all the listeners do as well. Like we said, check out your local Radio Shack to see what new stuff Parallax has out on the shelves now. It's really nice to be able to just go down to the local store and pick up this kind of tinkering stuff. It's been a long time since we've been able to do that in this community, and that's a wonderful step back in the right direction.
Mm-hmm.
You can find this show every week on Tuesday at firstspin.tv.
Cool. Sounds good.
All right, that's it for me.
See you guys next week.
Bye.
Bye.
Later.